we are going to learn how to simplify a radical expression. So what is a radical? A radical is also known as the square root sign. The number that is underneath the radical is called the radicand. To simplify a radical expression, what we are going to do is remove all perfect square factors from underneath the radical. When the radicand is a perfect square, the radical can be simplified so that there is no square root sign in our final result. So if the radicand is a perfect square, meaning that the radicand can be created by multiplying two expressions that are the exact same together, if it's a perfect square, your simplified result will not have a square root sign. So you will notice on the back side of your notes that I have a list of all of your perfect squares up through 15. I do expect for numerically you to know all of your perfect squares through 15 times 15, which is 225. We also have variables that can be considered perfect squares, okay? If our variable term has an even exponent, so x squared, x to the fourth, x to the sixth, x to the eighth, those are perfect squares because x squared is created by multiplying x times x. X to the fourth is created by multiplying x squared times x squared. So x to the 10th would be x to the 5th times x to the 5th. So when I square root those variable terms, what I need to do is I need to divide that exponent by 2 to take the square root of it. All right, let's work a couple examples. So the square root of 25, we know that 25 is one of our perfect squares. 25 is 5 times 5, so the square root of 25 is equal to 5. Okay, when I am square rooting fractions, and the square root is over the numerator and denominator of the fraction, we would take the square root of the numerator and the square root of the denominator. So the square root of 4x squared, square root of 4 we know is 2. And the square root of x squared, we know from our little chart here, is equal to x. So our numerator is 2x, and when we square root our denominator, which is 9, we get 3. Then we have the square root of 121, x to the 4th, y to the 6th, and z to the 10th. So since I have multiple terms here, we need to square root each individual piece of this expression, okay? There are 4 different factors: 121, x to the 4th, y to the 6th, and z to the 10th. So if I square root 121, I get 11. And the square root of x to the 4th, we know, is x to the 2nd. And the square root of x to the 6th y to the 6th would be y to the 3rd. Then we need to square root z to the 10th. So that would be z to the 5th. You just divide that exponent by 2. So our answer would be 11x squared y cubed z to the 5th. Okay, now, really the focus that we need to look at here is what happens when there's not a perfect square, okay? It's pretty straightforward. When we have perfect squares, we take our square roots and we have our final answer. But we can still simplify a radical expression even if you don't have a perfect square underneath the square root sign. So in order to simplify when there isn't a perfect square given, you need to make sure that there aren't any factors that have perfect squares underneath your radical sign, okay? And because you aren't starting with a perfect square, your final result is going to have a square root sign as part of the solution. All right, let's throw some variables in here as well. Okay, so the same idea of how we deal with our numbers. You're looking for a perfect square that is a factor of whatever number is given. So we're going to be looking for, in examples H, I, and J, we're going to be looking for perfect squares that are factors of 40 and 232, all right? In addition to that, we need to deal with our variables. So we said above that if your variable term has an exponent that is even, then you can take the square root and you just get and divide that exponent by 2, and it comes out of the square root sign. All right, for our next problems here, we do have some even exponents. However, what happens if there are odd exponents, okay? We need to split these variables apart using the same idea of creating that perfect square factor. So if you look at your list over here, first off, if you have just a single variable like the square root of x or like the square root of y in example I, then that variable, that individual single variable, is going to remain underneath your square root sign. Nothing can be simplified there, okay? If I have a variable to the third power, so x to the third power, I would split that into x to the second times x. All right, so you have x to the third, take away one of those x's, okay? And so you're subtracting one from your exponent. That creates your perfect square factor for that variable term, okay? We know that the square root of x squared is going to give me x, and then remaining underneath the square root sign is that additional x variable. So let's look at x to the 7th here. We want to split x to the 7th into x to the 6th, so I just decrease by 1 times x. So the square root of x to the 6th we know is x to the 3rd, and we have an additional x remaining underneath the square root sign, okay? So anytime that your exponent is odd and you're taking the square root of that expression, you're going to have a variable remaining underneath the square root, just the 1, and you're going to have part of that variable on the outside of the square root as well. All right, so let's look at square root of 40y cubed z to the 5th. So the first thing that I'm going to do is I'm going to split this down into my perfect squares, okay? So I know that 40, looking at it, I know that 4 is a factor of 4 times 10, all right? So we're going to start with that, and I'm going to have the square root of 4 times 10. Now let's look at our variables. So that took care of my 40. How about y to the 3rd? So when I'm dealing with an odd exponent, I want to take 1 away from my exponent. So I'm going to rewrite y to the 3rd as y to the 2nd y. All right. And then how about z to the 5th? Same thing. We're going to take 1 away from our exponent. So z to the 5th will become z to the 4th times z. Okay, so I have 3 perfect square factors underneath this square root sign. I have 4, y squared, and z to the 4th. So what I'm going to do next is I'm going to square root those 3 pieces of this expression. All right, square root of 4 is 2. Square root of y squared is y. Square root of z to the 4th is z to the 2nd. Remaining under the square root are the 10, the y, and the z. Let's do another one. Square root of 200 x to the 7th, y, z to the 2nd. Now, 200, similar to 72 above in example F, has more than one perfect square factor. We know that 4 is a factor of 200, and we know that 25 is a factor of 200. And when we multiply 4 and 25, we get 100. 100 is the largest perfect square factor of 200. So we're going to split 200 into 100 times 2 gives me 200. Now, x to the 7th has an odd exponent, so we need to change that into x to the 6th times x. Next, we have y. Y is a single variable, and so we cannot simplify that or break it down. It remains y. And then I have z to the 2nd. Z to the 2nd has an even exponent, which means it's already a perfect square. All right, so we have 100 times 2 times x to the 6 times x times y times z to the second. So we have 3 perfect squares underneath the square root. We've got 100, x to the 6th, and z to the second. Square root of 100 is 10. Square root of x to the 6th is x to the 3rd. And square root of z to the second is z to the 1st, or just z. Okay, so all of those 3 expressions that we square rooted go to the outside of the square root sign. Everything else remains underneath the square root sign. So we have 2xy under our square root sign. Alrighty, one more. We're going to switch gears a little bit. We've got -7, and that's being multiplied by the square root of 32xy to the 9th. So we need to break down 32 and y to the 9th, because x is just x. It's going to stay underneath our square root. So 32, we need to find the largest perfect square factor of 32. So 32, we know, is 4 times 8, but we also know that it's 16 and 2. 16 is a larger perfect square than 4. So 16 times 2 is what we'll split 32 into. So we've got 16 times 2, and then x stays as x, and y to the 9th is remember it has an odd exponent, so we need to take 1 away from the 9. So we'd have y to the 8th and y. All right, so we have 2 perfect squares underneath here. We have the 16 and the y to the 8th. So the square root of 16 is going to give me 4. And the square root of y to the 8th is going to be y to the 4th. Don't forget, we also had this -7 out in front. So we're going to pull that -7 down in front of the 4. Okay, remaining underneath our square root sign is 2x and y. So for our final answer here, we have to multiply the -7 and the 4. So we have -28 y to the 4th square root of 2xy. All right, so flip to the back side of your notes. Now let's talk about multiplication and radical expressions real quick, okay? Most of what we're going to do here on the back of our notes is what we just talked about in simplifying those expressions. But there is one thing we need to talk about real quick before we can get into all of that. So, to multiply expressions that involve radicals, here's what our rule says. Coefficients of radicals, that's the numbers in front, can be multiplied. Radicands, that's the numbers underneath, can be multiplied. Okay? So that's what you're going to do, is you're going to be given expressions that have coefficients and radicands, and we're going to multiply together. We're going to multiply the coefficients and multiply the radicands so that we have a single expression with a single radicand, okay, and a single radical. From there, we have to make sure that we continue to simplify so that there are no perfect squares underneath that square root sign. And I'm going to show you kind of 2 different ways to approach some of these problems. There isn't really a right or a wrong way. There is just 2 ways that you can look at it. And it's really your decision how you choose to approach the problem. First off, real quick here, we have the square root of 7 being squared. Remember, when something is squared, that means you're multiplying it by itself. So this is telling me that I have the square root of 7 being multiplied by the square root of 7. Okay? And because 7 is underneath the radical, I can multiply my radicands to get the square root of 49. And we know that 49 is a perfect square. So this is like those first few problems that we did in these notes. What is under the radical is a perfect square. So when I square root this, the radical itself is going to go away. So this would just be equal to 7. There is no radical, okay? 7 is an integer. So you might notice from the beginning, square root signs and squareds are opposites of each other, okay? So those two cancel each other out, leaving me with what was the radicand as my final answer, which is 7. That will always work. All right, so on our next example L here, we are going to go ahead and do our multiplication like I just talked about. When we're multiplying radical expressions, you can multiply coefficients. In this case, it's going to be the 3 and the 5. And then we can multiply radicands, which would be the 6 and the 5. So we start by multiplying the 3 and the 5, which gives me 15. And then we have the square root of 6 times 5, which is 30. Okay, at this point we need to stop and think, hey, can I simplify this expression any farther? And the answer here is no, because 30 has factors of 2, 3, 5, 6, and 15. None of those are perfect squares. You do need to mentally think that through, but it's not. So 15 root 30 times the square root of 30 is going to be your final answer. Now, if I look at our next example, M, we know that we can multiply the 6 and the 2 and we get the square root of 12. All right, so we'll multiply our radicands together to get square root of 12 is 2. Underneath the radical remains the 3. 2 times the square root of 3.
All right, starting with examples N and O, let's look at these two. They're a little bit different. We have the radical or the square root of 10x times the square root of 50xy. I could go ahead and multiply what is under these radicals together, and then I could simplify, or I could simplify what's inside the radicals first, and then I could multiply and maybe find that way to be a little bit easier. So looking at these two, I think I'm going to simplify first. So I'm going to go ahead and just copy the 10x down because the 10 has no perfect square factors and x is just x. So I'm going to leave that as the square root of 10x. I'm going to change this 50 into 25 times 2. I can see how 25 is a perfect square factor of 50. So I'm going to go ahead and take the square root of 25 and I'm going to bring it out front of my radical. And what would stay in the radical, okay, so now that I've taken the square root of 25, that is actually gone. So under the radical would be 2xy, and there are no more perfect squares under the radical there. So I would have the 2xy left under that radical. Now I can multiply much more easily, and I would do like we have an understood 1 here. So 1 times 5 is 5, so my coefficient still is just 5. Under the radical, however, I've got 10 times 2, which is 20. I've got x times x, which is x squared, and then I just have a y. So now I have to look again. Is there anything else now that I can simplify under that radical? Well, I can take that 20 and I can break it into 4 times 5, 4 being a perfect square factor of 20. My x squared is also a perfect square. So I'm going to take that square root of 4 and I'm going to bring it out front, where I'm going to multiply it with my coefficient that is already out there. So I'm going to multiply that out there. So now that 4 is gone. I'm going to take the, drew that a little bit early. So let's go ahead and take the square root of x squared, which would be x. Now that's gone. The 4's gone. So I have 5 and a y left under the radical. So to finish my simplification, 5 times 2 is 10, and the x in front of the radical with a 5y inside the radical. That's as simplified as I can make it. There are no more perfect square factors under the radical that I can actually take the square root of. All right, let's look at problem O. So again, I can simplify 60. I know it has a perfect square factor of, I know 4 goes into it 15 times, and then there's no other perfect squares in 15. So I'm going to break 60 into 4 times 15. And 45 has a perfect square factor of 9. 9 times 5. Okay, so I'm going to go ahead and take the square roots of those things and leave what's under the radical, what I can. I can also, if I wanted to, take the square root of y and x, but I'm not going to do that. I'm just going to worry about my numbers at this point, so I don't have to do 60 times 45 in my head and then try to find perfect square factors. So I'm going to go ahead and take the square root of 4, which is 2. So then I would do 3 times 2 in the front, which is 6. because I did 3 times 2. Okay, just showing you how I did that. And then what's left under the radical is the 15 and the x and the y squared. Okay, the square root of 9 is 3, so I'm going to do 2 times 3, and I'm also going to get 6 out front here. And so now that's gone. And what's left under the radical is a 5x squared y squared. Okay, so now I'm going to go ahead and multiply those radicals together. So I'm going to multiply my coefficients. 6 times 6 is 36. 15 times 5 is 75. So under the radical, I have, switch colors here so we can see it. Under the radical, I have 75, 15 times 5. X times x squared is x cubed. Okay, and y squared times y squared is y to the 4th. Okay, I now have a few things that I can do. I have a perfect square factor of 75, being not 5, sorry, 25 times 3. So 75 becomes 25 times 3. My x cubed breaks down to x squared times x, which we just did, and then I can take the square root of y to the 4th. So I'm going to pull out my perfect squares, which is 25 and x squared. I'm going to go ahead and, I should say pull out, but I'm going to take the square root of those things that I can and put them out front with the coefficients. So the square root of 25 is 5. So now I'm going to have 36 times 5. I'm going to take the square root of x squared, which is x, so that's gone, that's gone. Now I'm going to take the square root of, let me go ahead and write this so we don't forget to do this. I'm just going to bring that y to the 4th down. So I take the square root of y to the 4th, which is y squared. So now that's gone. So what's left under my radical here is going to be a 3 and an x. Okay, and then my last step is just going to be simplifying my coefficient out front. 36 times 5, well, 30 times 5 is 150, and 6 times 5 is 30. 150 times 30 is 180. Not 150 times 30, 150 plus 30. And then my x, y squared times the square root of 3x.